Now we are going to discuss a Laplace transform of a periodic function. If the function is said to be periodic, then how we are going to calculate uh, LT for that function. So before discussing numericals on that, we will derive an equation for the case of periodic function. Let us consider a periodic function of time period t satisfying the condition f of t plus nt, that is equal to f of t. This is the condition for a function f of t is said to be periodic. If the function f of t is said to be periodic, it has to repeat. The function f of t has to repeat itself after certain amount of time, that is after certain period, that is called as t, where any n is a what, it may be integer value. The n value may be positive integer or it may be negative integer. So this is the condition for mathematical representation of a function is said to be periodic. The periodic function is represented mathematically as f of t plus n capital T equal to f of t. Means this function f of t is going to repeat itself after certain amount of time. Now, if it is so, then the Laplace transform of such periodic function is given by f of s equal to 1 divided by e to the power minus s into capital T, where t stands for period or first cycle of the given function, into f1 of s, where f1 of s is the Laplace transform of first cycle. First cycle means the given function has so many cycles. The given function or the given signal has so many cycles, but uh, the second, third, fourth, fifth, whatever the cycles are there after first cycle, those are similar to first cycle. Because of that reason, we are calculating only LT or Laplace transform for the first function or first cycle. Now, consider one function, periodic function. This is what f of t. This function f of t is nothing but it is a periodic function. See here, this nature of the signal is going to repeat after certain amount of time. This is first cycle. 0 to t by 2, some amplitude is there, and t by 2 to t, it is 0. So this nature of the signal is going to repeat after this time. See, once again you are getting this nature. After this, once again you are getting this nature. He goes on getting same kind of cycles. So first we have to consider only first cycle. First cycle is means 0 to t. Then, so hence the given function f of t can be written as this function. We have to write mathematically as this is f of t. F of t equal to what? This one I will represent it as first cycle, first function, that is f1 of t, and this one I am going to represent it as. So when we are getting after shifting the function f1 of t by t seconds, nothing but it is about time shifting property. This nature of the signal is getting where it is present at capital T, nothing but you have to shift f1 of t by t seconds. Next, when we are getting this one, this nature of the signal we are getting at 2t onwards. So second one is what, minus 2t, third one is minus 3t, minus 4t, minus 5t, goes on. Now I will consider Laplace transform of first function. I am going to calculate this one, that is represented as f1 of s. Hence, we can write Laplace transform of function if we are writing the Laplace transform of first function f1 of t as f1 of s. Similarly, this function, if you apply the Laplace transform for this entire function, then we can write Laplace transform of f of t equal to Laplace transform of first function, that is f1 of t, plus Laplace transform of this function, then Laplace transform of this function, goes on. Same thing I written here. Now, if I represented Laplace transform of f1 of t as f1 of s, here same thing, then this one by using the time shift property of Laplace transform, this one we can write f1 of s e to the power minus st, and second function f1 of t minus 2t, we can write f1 of s e to the power minus 2 ts. Next, similarly, f1 of s e to the power minus 3ts, because 2t is there, 2t, 3t is there, 3t. Next, minus, next one is what, f1 of s multiplied by e to the power minus 4ts. Similarly goes on. If it is so, now from the above function, I will take f1 of s common, then f1 of s taking outside, left with what? 1 plus e to the power minus st plus e to the power minus 2ts plus e to the power minus 3ts. Okay. By using the mathematical formula, we know that Maclaurin series function, this is the Maclaurin series function. How we are writing that one? 1 divided by 1 minus x, 1 divided by 1 minus x is equal to 1 plus x square plus x cube plus x to the power 4 plus x to the power 5 plus x to the power 6, so on goes on. If it is so, this one we are writing as per the Maclaurin series, it is the Maclaurin series, then we are writing it as 1 divided by 1 minus x. Say compare these two equations. From comparison, we can the terms which are present in the square bracket compare with this one. We can say that one is there in place of x. What we are writing? E to the power minus ts. So here e to the x square means e to the power minus 2ts. X means what? E to the power minus ts. Hence, by using this formula, this one we can write Laplace transform of f of t equal to f1 of s multiplied by 1 divided by 1 minus x means e to the power minus ts. So same thing I am writing here. Hence here x is what? E to the power minus ts. 1 divided by 1 minus x means 1 divided by 1 minus e to the power minus ts is equal to same thing 1 plus e to the power minus ts, nothing but x. This is x square, that is e to the power minus ts square. X cube means plus e to the power minus ts whole power 3 goes on. Hence Laplace transform of f of t equal to f of s, that is equal to f1 of s multiplied by 1 divided by 1 minus e to the power minus ts. So this is the formula we are using for finding the Laplace transform for the periodic function. So let us see this concept with an example. Find the Laplace transform of the following periodic function. See here, this is the triangular signal. This triangular signal once again it is repeating after t seconds. So it is a periodic function. So as per the concept, first we have to calculate only Laplace transform for first cycle, that is 0 to t. So from 0 to t, time t equal to 0 to t, it is first cycle. But 0 to t, the amplitude is not same, it is varying. So because of that reason, I am going to split this first cycle as two parts, that is fa of t, nothing but this indicates 0 to t by 2. Once again, by using uh, straight line equations, I am going to find the amplitude for this duration uh, by representing the coordinates x1, y1, x2, y2. Here x1 is what? 0, y1 is also 0, x2 means this one, t by 2, and y2 is what? That is 1. Let us substitute these coordinates values in the straight line equations. Then we are getting y equal to 2 by t x. Y stands for fa of t, x stands for t. Hence fa of t equal to 2 divided by capital T into t. This amount of amplitude is present for the duration 0 to t by 2. Similarly, second part of the first cycle. Second part of the first cycle. This is second part of the first cycle. So that is represented by the coordinates x1, y1, x2, y2. X1 is what? That is t by 2. Y1 is what? 1. X2 is how much? X2 is to capital T. Y2 is how much? That is 0. Let us substitute these values in the straight line equation. We are getting y equal to minus 2 divided by capital T x plus 2. Y stands for fb of t, second part, and x stands for t. Hence, this term we can rewrite as fb of t equal to minus 2 by t into t plus 2. Hence, the Laplace transform of the first cycle, that is f of t, is equal to Laplace transform of first part of the first cycle and Laplace transform of the second part of the first cycle, that is fb of t. Okay. Now substitute the values. fb of t is what? 2 by t into t. 2 by t is constant. I will take it outside. Left with what? Only t. t into e to the power minus st dt. Limits are what? 0 to t by 2, 0 to t by 2. Similarly, second one, minus 2 by t into t plus 2, but 2 by t is uh, before that. First I will do the simplification of this one. Simplification of this one, we will get the answer as, simplifying this term, we'll get the answer as 2 divided by t into s square inside the bracket 1 minus e to the power minus t by 2 s minus ts by 2 e to the power minus t by 2 s. Okay. Similarly, second function is what? Fv of t equal to minus 2 by t into t plus 2. Apply the Laplace transform of this one. Now Laplace transform of the second part of the first cycle, that is fv of t. Laplace transform of fv of t equal to minus 2 by t is constant, take it outside, t into e to the power minus st. Second part is what? That is 2. That is constant, take it outside. 2 into e to the power minus st dt. Limits are t by 2 to t. Do the simplification of this part and this part, and finally we are getting the answer as fv of t, Laplace transform of fv of t equal to what? 2 by t s square inside the bracket minus ts divided by 2 e to the power minus t by 2 s plus e to the power minus ts minus e to the power minus t by 2 s plus ts e to the power minus t by 2 s, represented as equation number 2. So Laplace transform of the first cycle, that is f of t equal to adding first part of the first cycle and second part of the first cycle. So adding equation 1 and equation 2, we are getting the answer as 2 divided by ts square into inside the bracket 1 minus 2 e to the power minus t by 2 s plus e to the power minus ts. So as we discussed, Laplace transform of periodic function is what? F of s equal to 1 divided by e to the power minus t. T stands for period of the first cycle into s multiplied by Laplace transform of the first cycle. So already we calculated. This is the Laplace transform of the first cycle, correct? So substitute this one in the definition of Laplace transform of periodic function. F of s equal to f1 of s is calculated. This one, that is 2 divided by t s square 1 minus 2 into e to the power minus t by 2 s plus e to the power minus ts. This is f1 of s divided by 1 minus e to the power minus ts. This is t stands for period of the sigma. Hence we calculated Laplace transform of the periodic function. Likewise, we have to calculate Laplace transform for the given periodic function.